Hi, this is going to be a quick review of the newest segmentation model released by Meta. Some of the highlights mentioned by the company is that the newest SAM improves on SAM, the original one, for segmentation in images. It outperforms existing video object segmentation models, especially for tracking parts. And it also requires less interaction time than existing interactive video segmentation methods. You can check the homepage of this model in the address provided above. The original SAM method consists of an image encoder at the beginning that will produce image embeddings. Image embeddings are compact high-dimensional representation of images that capture essential features and patterns. SAM uses these embeddings to understand the content of an image. Once pre-computed, they allow the model to quickly generate segmentation masks in response to prompts. The mask decoder generates segmentation mask based on the image embeddings and prompts. It takes the encoded image and any prompts like points or boxes to produce a precise segmentation mask. A link to an overview of the original Meta SAM will be provided on the comments. Unlike the original SAM, the frame embedding used by the SAM2 decoder is not directly from an image encoder and is instead conditioned on memories of past predictions and prompted frames. It is possible for prompted frames to also come from the future relative to the current frame. Memories of frames are created by the memory encoder based on the current prediction and placed in a memory bank for use in subsequent frames. The memory attention operation takes the per frame embedding from the image encoder and conditions it on the memory bank to produce an embedding that is then passed to the mask decoder. You can find a link to the paper in the same homepage that we mentioned before. Let's use SAM2 on this video where we will be prompting two players, as you can see there, and see how the tracking goes with SAM2. Note the player highlighted by the arrow. SAM2 seems to miss it later on. Let's see on the same video what a popular technique YOLO can do for this. We will also highlight the player that is missing on SAM2. This is not meant to be a competition between the two models. Rather, if you think about it, you can do some post-processing on SAM2 and capture the missing player, or you can combine the two models. If you think about it, something can be done. Here is another example where we will be tracking the coin in three different backgrounds. As you can see, the first two are a little bit more challenging than the last one. Let's focus on the last video. We will be converting the frames into grade level value images. If we compute the histogram of one of them, we can see that the pixel values of the coin are mainly black when compared to the background. And as we can see, a simple threshold can do the segmentation quite well. Note for this particular frame how the threshold technique is missing some parts within the coin. This missing section within the coin can be easily corrected by morphological operations, making it still very fast. So once again, more than a comparison, we're just trying to mention here that we should be careful when picking the right model for a specific problem. It's not a competition. It is about picking a right engineering solution. In summary, these are some of Meta's claims. In video segmentation, we observe better accuracy using 3 times fewer interactions than prior approaches. In image segmentation, our model is more accurate and 6 times faster than the original SAM model. And that to enable the research community to build upon this work, we're publicly releasing a pre-trained Segment Anything 2 model along with the dataset, a demo, and code.